Hi, it's me Tutor Binod. In this video we are going to talk about friction, which consists of static and dynamic friction. We're gonna have the review of friction. Let us see different component of force acting on the block which is at rest on the table as shown in this figure. Suppose we applied force in this direction, then the frictional force always oppose the applied force, so it's in this direction. Also, let us consider x-axis to be this way and y-axis to be this way, which are the positive x and positive y-axis, and this is a normal reaction which is denoted by the green line over here, which is balanced by the weight mg of the body which is on the table. The Newton's second law of motion enable us to say that F is equal to ma, the force is equal to ma. Since it's a 2D problem, we can represent it in two-dimensional, one along the x-axis and one along the y-axis. Along the x-axis would be mass times the acceleration along the x-axis, whereas the y component will be m times acceleration along the y-axis. Also, if you can see in the figure, the normal component or the normal force N is upside, so let us write as N. Now mg is always vertically downwards, so it's in the opposite direction, so let me write it as negative mg, which is the weight of the block, must be equal to the mass times acceleration along the y-axis. Since the body is at rest, this acceleration along the y-axis would be 0, which would give me the normal force is equal to the mg. So this is how we got this one. Similarly, it is found that the maximum frictional force is equal to mu s times n, whereas the frictional force is mu k times n. Whenever the body is at rest, we talk about static friction, whereas when the body is in motion, we talk about the kinetic friction. Also, if you can see here, if you keep on applying the force, the frictional force would resist it so that the block cannot be moved. But if we keep on increasing the force to the certain limit, now the body tend to or will begin to move. That maximum amount of force at that time just before the sliding is called the maximum frictional force, which is equal to the mu s times n, which will be the maximum frictional force for the body. So whenever the object starts moving, then you can apply a little bit less force in order to have the body moving. In this case, when the body is moving, we talk about the coefficient of kinetic friction, and the frictional force would be mu k times n. Now let us talk about the friction when it is on the inclined plane. Suppose the body is at rest as shown in this figure. This is an object. The object is placed at an inclination of theta with the horizontal, so the weight of the body is acting vertically downward, which is equal to mg. The normal force is always perpendicular to the plane where the object is situated, so this will be the perpendicular force. And similarly, we can have another component of force exactly opposite to that of the normal force, so that we can have two components or two rectangular components of mg, one along the x-axis. In this case, we have axes in such a way that x-axis belongs to this direction, whereas the positive y-axis belongs to this direction along the normal force, which will make our calculation really easier. So the mg can be represented into two rectangular components, one along the x-axis and one along the negative y-axis. In this case, since this is theta, we can have this theta, because since this is theta, you can have this as theta. Now if this is theta, this is mg cosine of theta and this is mg sine of theta. So mg sine of theta is along the x-axis, which must be equal to the mass times the acceleration along x-axis. Similarly, for the y direction, our upward force is n in the positive direction, so I can write positive n. So mg cos theta is in the opposite direction, so let me write negative mg cos theta, which must be equal to the mass times acceleration along the y-axis. Since the body is not accelerating along the y-axis, our ay component would be 0, so that we can have n equal to mg cos theta. From equation 1 we can have m cancel out, so that ax equals to g sin theta. Now if we see here, but if you keep on increasing the angle theta to another level, keep on increasing the theta until it becomes maximum and the body just starts or begin to slide, then let us say our theta would be theta prime. In this case, my mg sin theta minus f must be equal to max, but this f just before it starts sliding would be equal to the maximum frictional force, which is known as mu s times n. My mu s is mu s, but n I got it as mg cos theta, so mg sin theta prime must be equal to the mu s mg cos theta, which will give me mg is gone, so mu s equals to tan theta, because sin theta prime over cos theta prime would be tan theta. This is how we develop the relation for the mu s, which is equal to the tan theta prime. So from these results we see that mu s must be greater or equal to tan theta in order to have the body at rest. As long as mu s is greater or equal to the tan theta, the body will be at rest, but whenever tan theta becomes greater than mu s, then the body starts to slide, which has numerous application in our real life. Similarly, let me tell you one more thing. Whenever the body starts to move, then if you want to see along the x-axis, my mg sin theta will be in this direction, whereas my force of friction will be in this direction, opposite to that of the acceleration. So force of friction must be equals to mu k times n, because in this condition the body is moving, so mu k times n. My mu k is mu k and n is mg cos theta. Let me replace it over here. Mg sin theta minus mu k mg cos theta equals to max. Now I can cancel m from all the side, so that I can have g common. Sin theta minus mu k cos theta equals to ax. So these are all the conditions we can derive from the body which is inclined on a plane, and if we want to talk about friction, we will have this kind of result. I hope this video helps you as a review material for friction. I also want you to subscribe my channel and hit the bell icon so that you will never miss my future videos. Also, I want all to be safe and healthy in this pandemic. Thank you.